Hello everyone, welcome to Pratibha Tech. In this video, we will solve the problem of the day question on Geeks for Geeks for 17th February 2023. The problem statement for today says, is it Fibonacci? This problem is based on arrays and sliding window concept. Let's now open this problem. So first we will go through the problem statement. Here it says, Geek just learnt about Fibonacci series. The Fibonacci sequence is the series of the numbers 0, 1, 1, 2, 3, 5, 8, 13, where the next number is found by adding up the two numbers before it. Okay. So it is simply about the Fibonacci series. Here it is saying that each number is the resultant of the summation of last two number. Here we can see this 5 is the resultant of this 3 and 2. 13 is the summation of 5, 8, this 8 and 5. So to get the next number in this series, we need to add the previous two numbers. Now what it says further is that he defines a new series called geeky numbers. Here the next number is the sum of k preceding numbers. Okay, so in Fibonacci series we need to do the sum of last two numbers, but here instead of taking last two numbers, geek is taking last k numbers, that means k preceding numbers. You are given an array of size k geek num, where ith element of an array represent ith geeky numbers. Okay, return its nth term. Okay, so the problem can be solved in O of n square time complexity, but the user has to solve it in O of n. The constants are less because here there can be integer overflow in the terms. Okay, so here it is saying that we need to solve it in big O of n time complexity. So we'll try solving it in big O of n time complexity only. So here let's go through the example here. So first it is saying that n is 6. That means we need to find the sixth index. That means there's sixth term in the sequence where the k is 1 and geeky number contains only one number as of now. So how this person has defined his series, he will add previous k numbers to get the next number. So here previous k number was 1 only. So to get the next number in the series, he has only one option, to add 4. So here the next number will be 4. To get the next number, again he had to just add previous one number. But one number is again 4. So the sequence has become 4, 4, 4 up to 4, up to 6th nth terms. Now let's look at this second example. Here n is given as 5, k is given as 3, and geek num array it has 0, 1 and 2. And here it says that to get the next number you need to add last three numbers. That means three previous numbers you need to add to get the next number. So here the output it is saying as 6. That means the fifth term will be 6. And how it is that the terms are 0, 1, 2. This was given. So once we add these 3, then we will get 3. We will get the next term in the series, that is 3. Now once we got this term 3, now if we add last k numbers, that is 3 numbers, we will get 6. And here this is our fifth term. Okay, so here it is 6. So here what it is generally happening here is that means you need to just add k numbers here as it has been added here with 0, 1, 2, 3, 6. See, if we have to define our series further, then again we have to follow the same thing. Here since k was 3, so we need to add last 3 digit. So here it will be 6 plus 3, 9, 9 plus 2, 11. So it will be something like this. The next series will be 11. So this series will continue that way. So here the approach with whatever we will be taking, that I'll be explaining in this one. So what we will take, see, initially we will start with 0. That means our for loop will start with 0. Our iteration will start with this index. And to get this fourth one, to get this 3, what we need to do, we need to add this 3. These three. So if our correct index is pointing at this one, and if to this current index, if I add my value of k, that means I add my window size. See, this can be even considered as the problem of sliding window. So each time we will be considering a window of 3 to do a summation, and after each iteration we will be just decrementing the size of the window. So when initially, when we are pointing at this index, so to this we will take, when we are pointing this one, we will take these three number, because here we need to point to first k numbers. Here k is 3. So when I is pointing to this one, our j will be pointing to, our j will run from this to this. This to this means up to size of k. So we will add this, and we will simply, this is a array list, this geek num, so we will simply add into that one. Since this is that concept of that array list here, we can just append it, just add it there, so it will be stored in the next index. So when I becomes 1, so now again the sliding, my window size will be from this I is equal to 1 to this 3. So now we will perform the summation of these three, and we will again add it to geek num. And for each inner iteration of j, first we will take the summation of 0 plus 1. Then whatever the summation we get, then we will take that summation plus 2. Then again for the next iteration, that summation plus 3 for the inner loop. So that's why we will be decreasing the size of the window there. So, and this we will continue up to n, that means till we get the n. Okay, so now let's based on this approach only, let's now try coding the solution. So here what we can write, here we can write for int I is equal to 0, I less than n, I plus plus. Here I'll just define a counter, because each time we need to store the summation of last three numbers, so each time I need to initialize it with 0. Now whatever I was talking about, the inner for loop, that I am writing now, starting with int j is equal to 0 here, then j will be less than k, that means the size of the window. So each time the j will start from 0 and it will go up to size of k, and this will be j increment. So now here what we will do, to this sum variable, whatever we will initialize here, sum is equal to sum plus geek num of 0, sorry 0 here I plus j. See here, if we do not include I here, then each time it will do the summation of first three numbers only, because j will be pointing to 0 and it will go up to k. So every time if it is 3, then it will always give the next number as 3 3 3 3, something like that. So what we need to do, once we are done up with one number, then we need to increase the value of I also. So it will be I plus 1. So next time it will take from this index to next up to k numbers. Okay, so here so suppose if we are currently at I is equal to, sorry I need to write here I, yeah, so if you are starting with here that I is equal to 3 or I is equal to 4 here pointing at 6, so through this one what we'll do, j will start its counter here, where at this number where j will be 0, j will be 1, j will be 2, something like that. So whatever the next number we will get starting from this IS index, from here the window size will be defined up to k. So that's why this I plus j is done, because if we do not include this, again we will get only the every time the sum of these three. So whatever is the current index at I pointing, from there we will take k position. If it is pointing at 3, then from here we will take next k size. So for that only this I plus j is done. So now once this summation is done, sorry, control Z. Once the summation is done, then what we can do, we can add it to the series. Geeknum dot add is sum. Okay, now we need to return the nth term. Return geeknum dot get of n minus 1, because if you have to get the fifth term, then the index will be, since it is starting with 0, so we have to return n minus 1. Okay, so here n minus 1, because here we have to return the fifth term, so it is starting from 0, 1, 2, 3, 4. The whatever we are getting at array list of index as 4, that we will return. So that only I have done here. Okay, so I think I'm done with my coding. So let's try compiling this code. Again some mistake is there. Cannot find symbol geeknum. Oh, sorry, this is not an array, this is an array. This is array list, so we have to use get method there to get the value at the particular index of I plus j. Now let's try compiling it again. So here we can see we have got our output. Now let's try submitting the solution. So here we can see we have got all the test cases covered. Yeah, but one thing to take care here. See, we are going up to n. And the concept we discussed, that whatever is the current location, that means current index of I, from there it will take the next k indexes. That means it will calculate for next k window size. So even if you are pointing to size of n, that means the last index, it will again calculate for next k size window, the summation of all the previous elements. That means it will even continue for the next k elements because of that window size. So that is not required, right? See, if you have to return the size, if you have to return the number at series of at position n, then why we need to calculate the rest of the things? So it is better that we need to restrict it till k. So just we can write here n minus k. So it will run for n, the outer loop will run for n minus k, and inner loop will run from 3 to 11. So if we have to get the output for this series, and for this nth term of the series, then outer loop will run till this, and inner loop will take care from this to this. We do not have to run till n, because it will create in this series, it will add 2-3 extra element or k extra elements. That is not required. I hope this is very clear. So now let's try again compiling the code. Okay, even now we have got the answer correct. Now let's try submitting this. So here you can see that this even with n minus k, we have got our solution correct. Yeah, but in fact this is more appropriate one. This will take a little less time and little less space also. So it is much optimized solution. That means outer loop will run till n minus k, and inner loop will continue from n, that means n minus k plus 1 to n to up to n, so it is much better solution than the previous one. So here we can see that we have solved our problem successfully. Yeah, so that's all in this video. Please like, comment, share and subscribe to the channel for more upcoming videos. Thank you for watching.